I warmly welcome you to all in today's APAC Data 2030 Summit. Currently, everywhere you can listen the buzzword data, data, data. So what is the importance of data? Why it's important for any organization? How can you use it wisely and securely on cloud? Hi, my name is Atul Mistry and I'm working as a cloud architect with John Foord. And I'm going to discuss the cloud data strategy, how to use it wisely and securely. So I'm going to cover the following topics: Jeff analytics in brief, then case study or the problem statement, then data everywhere, then data lifecycle, and then how to secure data on cloud. And finally, I will discuss about the architecture and the solution. So now let's go to a brief introduction about the JF Analytics. So John Foord Analytics is a subsidiary of John Foord. It was founded in 2018. It is a comprehensive, global, and simple to use an online platform to help owners, insurers, and advisors estimate current reinstatement costs for fixed assets across their whole portfolio. It is powered by John Foord, a leading independent global asset valuation practice. The all-new platform provides real-time data to clients on reinstatement values for a vast array of asset types and occupancies across the world, containing the experience and data of decades of valuation history. John Foord Analytics is driven by proprietary models and algorithms based on tens of thousands of hours of data science analysis. The platform applies the latest in artificial intelligence and machine learning technologies. John Foord Analytics supports insurers, advisors, financiers, and asset owners who wants to secure accurate and straightforward reinstatement costs delivered instantly anywhere, anytime. As discussed in my previous slide, we are in the asset valuation business. The process to determine accurate values at risk for insurance hasn't changed in decades. After COVID-19, the world of insurance valuation is changing rapidly, and providing that traditional site surveys are becoming less in demand. Wrongly insured assets are a global problem, costing billions of dollars of underpaid premiums to the international insurance markets. So here the first problem is cost. One of key data from Lloyd's shows that there is an annual gap between the levels of insurance needed and the actual cost of underinsurance, approximately $168 billion globally. We have been running beta trials with major insurers on our platform. From a sample of 80 assessments across the power and building sector, we found that there is a more than 10 billion USD is under insurance. The second problem is lack of data synergy. So use of indices is not accurate, not standard data sets are available, and we are also unable to find out the qualified personnel. The third problem is it requires extensive team of appraisers. So currently, the valuation process is taking 4 to 6 weeks, and it relies on a team of professional valuers. It is difficult to scale. And the next point is time consuming. The process is time consuming from days to weeks. Sometimes companies lose the opportunities as well, and it will also delay the settlements. The fifth one is poor risk selection. Currently, less than 10% of assets get valued due to challenges of getting data, and it is not cost effective as well. So now let's go to the next topic, data everywhere. So as you know that data is everywhere, and I will try to categorize it under different sections, like what refers to big data, how data classification happens, what are the different states of data, and how data can be categorized and used in data science and research. So in big data terms, generally we can refer 5 V's in big data. So it will be volume, variety, value, velocity, and veracity. So for the volume is a huge amount of data. Variety, it's a structured, semi-structured, and unstructured data. And further categorized into the structured data, it's an organized data, it is stored in a relational database, and it has been predefined the length and form of data. Another is semi-structured data. So semi-organized data, it is not in the predefined form of data, and we can say that the examples are log files or CSV files or XML or JSON files. And we have unstructured data. So unorganized data, it cannot be stored in a relational database. And examples are images or video files. Again, we can go for the value. So data needs to be converted into something valuable to extract relevant information or useful information. Then fourth one is the velocity. So high speed of accumulation of data. Then there is a veracity. So uncertainty and inconsistencies in the data. The quality and accuracy of data are difficult to control. Then I can go for the data classification terms. So I can define as a two categories, public data and the private data. So for the public data, this data is easily available for public access. Private data, this data cannot be available easily for public access. And I can further categorize them into three subcategories. First is internal data. So non-sensitive data that will be used internally and can't be accessed by the public. Then confidential data, it contains sensitive information and is available for internal distribution as requested. And there is a restricted data. So this is highly sensitive data with very restricted distribution. Then I can again classify as a different states of the data. So data is data at rest, data in transit, and data in use. So for the data at rest, this data is stored in a database or data store or data lake or in operational system, and no one is accessing it or using it. To protect the data at rest, you can encrypt and store it, or you can restrict the access of this data. So the data for the data in motion or data is in transit. So it will be mentioned as data is transit from one location to another in the packet form over the internet. It can be protected using encrypted pathways by SSL or TLS. Generally, the most secure communication channel is direct connections from cloud providers to clients or using a secured VPN over the internet. The third one is data in use. This is the state when data is used by the application or system to provide some valuable information. It is super important to secure the data when it is in use. Then the next point is in data science. So I can further generalize or categorize this data into two ways. First is the quantitative and the second one is the qualitative. And both are equally important. You can use both types to demonstrate effectiveness, importance of the values of the data. So first one is the quantitative data. This data can be measured by numbers. Second is qualitative data. This data cannot be measured by numbers. It is symbols, words, and pictures. The third one under the quantitative data is discrete data. So it contains only integers like a person in the office. It cannot be 10.5 people. It will be either 10 or 11. The fourth one is continuous data. It contains any numerical values like height, weight, temperature, etc. Under the qualitative data, there will be two subcategorized in two parts. One is the nominal data. So it will be useful to labeling the variables like marital status or gender, etc. And for ordinal data, this is ordered data, but not in a nominal data. So for example, there will be a competition and we will mention that, okay, this is first one, second one, and the third runner-up. So using the data science, you can solve complex business problems in your organization by leveraging advanced analytics and machine learning. You can also provide, or you can also develop the data monetization strategy by leveraging your data to obtain measurable business benefit. By leveraging and considering customer behavior, you can get insights for personalization, micro-segmentation, loyalty, rewards, subscriber retention, etc. You can also consider your data to sell via marketplace. Also, your focus should be on transactional values to complete understanding of the business transactions. Also, analytical values to automate the activities to predict outcomes, and informational values to understand past performance. So another point of consideration is data governance. To meet stakeholders' expectations, you should have controlled your data, and you will provide access those data to the right people by assigning right roles. You can also standardize data lifecycle policy and includes continuous compliance monitoring. You can also prioritize your data quality and monitoring it at every step in the life cycle, in the data life cycle. So now let's discuss about the data life cycle. So data is the most valuable asset for any organization, and data is always growing. Extracting more values from this data is the objective of the organization. It can be achieved by data lifecycle management. So data is generated from the source, and it moves from different stages like ingestion of data, storing it, processing it, analyzing it, and visualizing it to provide output that can help in the decision-making process. Mostly all cloud service providers are catering different services for different stages, and you will get relevant service information using this available link. So if I will go to that link, it will provide me information that how different services are related with each other. So if I will consider the most important or major cloud vendors in the market, so this sheet will provide you the information about the Google Cloud products and AWS offering and Azure offering. So if you are very good in Google Cloud, and if you want to relate for the AWS offering, you can just check it out for those same services. Or I can say that if I want to search, I am very good in AWS, and if I want to search for the Kinesis and I want to know that which services available in Google or in Microsoft Azure, I can immediately identify that which service I want to use if I will go for the Google or Microsoft Azure. Coming back to our slides. So in this one, I have mentioned the different stages of the data lifecycle. So first one is the source. So data source is the data that is generated from different sources and ingested into the system. The data source can be web or mobile applications, APIs, ERP systems, clickstream data, or database, etc. This data can be in raw form and help to get some meaningful information. Second point is ingestion. Once the data is available, it will move from the local system to the cloud service provider's system. During this phase, the source of data can be identified, validated, and import the data. If I will discuss the AWS perspective, AWS is providing services like AWS Kinesis for real-time data movement or real-time data streaming, AWS Snowball to move the data from on-prem to the cloud, AWS Direct Connect, and also providing the AWS DMS for the database migration systems or services. The third point is store. So before the data is available for process, it is always best practice to store the generated raw data. These data are generated from users, and they can be structured data or semi-structured data or unstructured data. So in AWS, it is providing services like Amazon Simple Storage Service, Amazon S3 to store all kinds of data. AWS Relational Database Service to store structured data, and AWS DynamoDB Service to store semi-structured data. Once the data is stored, it will be available for the next phase to process it. You should prioritize your data quality efforts for the application of platform with the correct strategy for the overall operational needs. You can establish the organizational standards for data quality by business roles, identify right keys, quality attributes, and metrics. The fourth one is process. It is also known as the preparation stage or preparation phase, where data is prepared to use for the next stage. This process can happen during this phase by using the data wrangling, or sometimes it is known as the data cleaning. So during that phase, it will process by modifying data, removing corrupt or inaccurate data, and removing data that is not useful for the particular process. You can also consider the data compression. Data can be compressed in such a format that can be stored more efficiently and cost effectively. So during this phase, it also includes other operations like processing the image file, audio file, or video files, and extracting text from them, adding metadata tags to that file, creating thumbnail files from the images, or translating files into a different language in languages So in AWS, it is providing services like AWS Glue or Amazon EMR, AWS Lambda function, and AWS Temp functions for the orchestrations. It also includes some of the other services as well that I'm not going to cover in this session. The fifth one is analytics and visualize. So once the data is processed, then it is ready to ingest for the analytics service. It will give you the true value of data for decision making in this phase, and it can provide more information about the needs of customers and the improvement of operations. AWS is providing services like Amazon Athena for analytics. Visualization of data will help organizations to understand the personalized requirements of customers. AWS is providing services like Amazon QuickSight for visualization purposes. And the last step is archiving. So in archive, data will be archived in this stage. It will be stored as per the organization's compliance requirements or policies. It will also manage the security standards of the organizations and will reduce the storage cost. Organizations can store the archive data as per security standards in a cost-effective manner. AWS is providing services like Amazon Simple Storage Service, Amazon S3, or Amazon S3 Glacier, Amazon S3 Glacier Deep Archive, and many more. Now, let's discuss how to secure it on the cloud. So how to secure data on cloud? So here, my first point is to know your data. To secure your data, you need to know exactly what types of data you have. Data discovery tools can be used to scan the repository and provide the findings. Later, you can classify your data and store it accordingly. One of the main objectives of security of data is to protect it from unauthorized and unintended access and potential vulnerabilities. To help you determine appropriate protection and retention controls, classify data based on criticality and sensitivity. Define data protection controls to provide the different access and lifecycle policies for data. Store your sensitive data in a secure location, and it can be accessed by authorized users only. In this way, it will reduce the risk of data exposure and loss of data. My second point is shared responsibility model. So in Amazon Web Services, AWS has segregated security and compliance into two categories, and I strongly believe that it is also applicable for other vendors as well. So in this model, the customer is responsible for security in the cloud, whereas AWS is responsible for security of the cloud. It means customers' responsibility is to secure their data and their customers' data, identity and access management, operating systems, network, firewall configuration, etc. Also for the client side and server side data encryption, traffic protection, authentication, and authorization. Whereas AWS is responsible for protecting the global infrastructure. Now, let's understand the defense in a depth approach. So in this way, we will drill down different approaches that how the persons can go and take your data or use your data. So I can say that it will be divided into 4 different components, and it will show that how you can secure customers' data in a cloud environment by using different services. So the first one is the network security. So you can allow only legitimate traffic to access your data, and other traffics can be blocked. It will reduce the surface area of attack. You can secure it using network access control list that will allow providing zone-based access and security groups and network control access list to secure the individual components. The second one is access management. This includes authentication and authorization. Authentication is the process to verify the identity, whereas authorization is the process of granting permission to the user on resources. It can be achieved by identity and access management, IAM. By using IAM, it will help to grant permission or restrict it to the users. or groups and roles to access different services on the cloud or access the data. In a database table, an administrator can provide row-level security that allows users to execute queries on limited rows in a database tables. In general, the admin is following the least privilege access principle and providing minimum access to the user and amending it on a need basis. You can also implement a strong password policy for the user in organization-wide and mandatory multi-factor authentication while accessing secured sensitive data. The third one is a threat protection. So to monitoring and auditing and analyzing logs help to detect any unusual behavior that can be harmful and accessing data. Organizations can create alerts and trigger events to prevent such kinds of suspicious activities as brute force attacks, cross-site scripting, DDoS attacks, SQL injection, or access to the applications in a blacklisted country. The fourth is information on or the data protection. So data in transit. In this one, the customer data can be communicated securely across a computer network with SSL or TLS, and transport layer security protocol. Data at rest. Customers' data can be secured by transport data encryption TDE, which adds a security layer to access from outside the database. While if the data is stored in object storage like AWS, S3, then it can be secured using server-side encryption or cloud or client-side encryption. Encrypt all your data at rest and in transit. So you can store your sensitive data in a separate AWS accounts. Also, you can store the encryption keys into the key management system, and it will be set up for rotation at a certain interval as per the organization standards. Sensitive data can be masked to display to non-privileged users. If you are using Amazon S3 to store your data, then you can use the Amazon S3 object lock features that will allow storing data by write once, read many warm model, and it will prevent amending any changes to the data once it has been written to the Amazon S3. This will also satisfy compliance requirements for your financial or healthcare data. So now let's come back to our previous slides and the case study and the architecture. So basically, we are in the valuation business for the last 200 years, and we have lots of historical data. So to maximize use of those data and be a part of the digital revolution, we have decided to go for JEF analytics. So we have around 30 years of valuation data, and it is more than 4 TB. It contains valuation reports in Word documents, PDF files, Excel sheets, images, and many other informations. So we are using AWS Cloud to deploy our application. It will provide a reliable, scalable, and secure application development and deployment environment. And based on our experience, we have our own proprietary modeling algorithms that can help us to provide accurate results. This is the architecture of the platform. In this architecture, you can see that we are using Amazon Web Services heavily, either for authentication and authorization, or for the users, or storage of the data, whether it's a structured, semi-structured, or unstructured data, or we are also using that triggering the notification events. Also, we are using the serverless Lambda functions that will be called from the API gateways. And we have created our machine learning algorithm or models that provides the operations dashboards to the management as well. So you can see all the components over here in this architecture diagram. And for the solution, so I can say that JFA solution is providing, it's the motto is kind of adapting to the new way of working. So in this one, I can say that we are providing the or improving the data collection. So in this platform, it is collecting the global asset data in real time. Aggregation and integration of data are also central of the concepts. The standard data set or indices get up-to-date information using the application programming interface. It will also provide the correct risk pricing, and using the most appropriate data helps to provide more accurate premiums to the markets, and it will also correct the under insurance. It will help for the global deployment, and it will also useful when it is going into the every insurance offices globally. It offers a real-time global insurance valuation solution. It will also help us to improve the client retention. So getting the accurate valuation information instantaneously gives an improved services to the clients and markets. So as I mentioned in JF, we are using artificial intelligence and machine learning that helps to simulate, extend, and expand the intelligence to create intelligent ML models. And if I will discuss about the AI/ML benefits, it will provide us the valuable insights. So companies can discover more valuable insights into the structured, semi-structured, and unstructured data sources. It will also help to provide the precise and faster decision making. AI can help to reduce human error, and ML can use to improve data to create the models, and with both the combinations, it will help for the faster and precise decision making process. And it will cater to the client's accurate and up-to-date sums insured. It will automate the sums insured valuation process. It will be faster asset quantification, classification, valuation, and giving the latest information to the clients. Thank you all for listening to me. I hope it will be an informative session for you all. I'm happy to answer your questions if any, or you can drop me an email at atul.mistry@johnfoord.com. Thanks, and have a nice day ahead for the rest of the sessions. Thank you so much.